Okay, today we're looking at log transformation. So what happens when we change our parent function of y equals log x? So the first thing we want to do is look at the graph of y equals log x. We go to y equals log x. Remember, this assumes a base of 10. It's our common log. When we look at the graph of that, oops, that's the table. Look at the graph. Okay, we see it comes down and then it comes up. We want to plot some actual points. So if we go into our table, we see the point 0, where x is 0, there's an error. That's because we have a vertical asymptote. The point 1, 0. The next clean point we have will be down here at 10. We also have the point 10, 1. Okay, now we've talked about how this graph has a vertical asymptote, so it gets closer and closer to 0, but it never actually touches it, so it continues on in that realm. So if we look at the domain gets really close to 0, but never actually touches it, so 0 with a parenthesis, and then it continues on to the right, so to infinity. You could also say x is greater than 0. The range, our graph continues down forever, and it also continues up forever, so the range would be negative infinity to infinity. You could also say y is an element of all real numbers. Either way is fine by me. Okay, so then part B says we want to graph the log of x plus 2 in blue pen to the right. So we're going to come back into our y equals. We're going to graph the log of x plus 2 outside of our parentheses. If we look at our table, if we go back, now we're going to have the point 1, 2. And if we go to 10, we'll have the point 10, 3. Okay, and again, it still doesn't actually touch the y-axis. Okay, then if we're going to come in, so if you notice, your graph is kind of moved up too. If we look at C, we want us to graph the log of x minus 1. So we look at our table. Here we have the point 10, 0. We go back up to 1. So we're going to keep using those same points since they hit nice and neatly. 1, negative 1. Okay, and then again at 0, it's still got your error. So now it's going to look like this. Okay, so if we notice, when we added 2, in blue, when we added 2, that took my graph and shifted it up 2. When we subtracted 1 outside of the parentheses, again, both of these are outside of the parentheses, that shifted my graph down 1. Okay, so this next part, we're going to start with our same graph. We still have the point 1, 0 and 10, 1. Still have that vertical asymptote. Okay, so there's my original. Now it wants me to graph the log of x plus 2, but notice now my x plus 2 is inside the parentheses. So back up here, got x plus 2, close the parentheses. When we look at my table, okay, now we've got a point at negative 1, 0. Oops. We come down here to find our next clean point. Now it's at 8, 1. Okay, and if you notice the asymptote, we have negative 1, 0. Now my asymptote is at negative 2. So it comes down and approaches negative 2. Okay, C wants me to graph the log of x minus 1. So we're going to come in and make this minus 1. Okay, now you see we have our asymptote starts at 1, because that's where we go to an error. So we have a vertical asymptote at positive 1. We have the point 2, 0. And we also have the point 11, 1. Already see it there. Okay, so when we look at this, when we've added 2 inside our parentheses, the plus 2 inside our parentheses, which is the blue, it moved my graph from here, it moved it to the left 2. So a plus 2 inside the parentheses went left 2. Just like everything we've looked at before, when it's inside the parentheses, it goes opposite of your intuition. So a plus 2 went left 2. A minus 1 for my original moved to the right 1. Okay, so the same ideas that we've seen before are all just happening again. Okay, so the third area is where we're going to look at our reflections and stretches. So again, we start with our 1, 0 and 10, 1. Okay, so the first thing we're going to look at is if we have negative log x. So come back up here. I'm going to put a negative in front. And we just have log x. So a negative log x. Here we've got the point 10, negative 1. Come back up. We've got the point 1, 0 as well. Okay, but if you notice, all of these points are getting increasingly more negative. So my graph has an asymptote still vertical, but now it's going the other direction, and it comes out to positive infinity. Okay, so if we look at it, that negative in front, that reflected my x-axis. This is my x-axis. Okay, I'm going to come down here and fill it in. So the negative in front of the equation reflects x-axis. If you look at C, it wants to see what happens if we put the negative inside. Okay, if you can't see it, there you go. So we're going to come back in. Now instead of having the negative there, we're going to come inside and have negative x. Now when we look at the graph, here we've got zeros, all of our errors are here. Oops. Go back the other way. So we have the point negative 1, 0. Okay, so we'll plot negative 1, 0. I'm going to keep going up because that seems to be where my numbers are. Then we have the point negative 10, 1. Okay, and again, we had all errors when we went 0 and positive. So now if you notice, my original graph went up and to the right. This new graph comes over and down. So now it's reflected across the y-axis, because here's my y-axis. So when that negative is inside my parentheses, so the log of negative x, that reflects the y-axis. Okay, which is why it's really important to tell me which axis you're reflecting, because it depends on where that negative is, where it reflects. Okay, D and E, we want to go ahead and fill out this table first. That's going to help us graph our stretches and shrinks. So if we come in, we're going to say we've got the log of plain old x. Then we want to graph 3 log x. Finally, we want to do 1/2 log x. I'm going to go ahead and do 0.5 log x. Okay, when we look at my table, go back up. Oops, wrong way. Okay, so in all of these, we have the point 1, 0, 1, 0, 1, 0. So for all 3 of them, we have the point 1, 0, 1, 0, 1, 0. I'm going to look at 5. So when we look at an x value of 5, on y1, which is my log x, we have 0.699 basically. So 5.699. Okay. On y2, which is my 3 log x, we have the point 2.097. And then just hitting the right arrow. To get my y3, which is my 1/2 log x, we have 0.349. Okay, so then finally I'm going to go down to an x value of 10. Okay, so we have the point 10, 1 for my first graph, y1, 10.3 for y2, and y3 is 10.5. Okay, so we're going to use those numbers to graph our functions. I'm going to do this first one. Okay, so we're going to do log 3 of x in our black pen. So log 3 of x, we have the point 1, 0. So 1, 0, same point as all the other ones. Then we have the point 5, just a little bit over 2. And we have the point 10.3. So if you notice, it has the same starting point as my original, but instead of being up 1 unit, it's up 3 units. So it's 3 times as high. I'm going to use this one in green, so instead of red, I'm going to use green. So my 1/2 log, we have the point 1, 0. We have the point 5, 0.3, and we have the point 10.5. So now it's only coming up half as high. Okay, so this is vertically stretching it or shrinking it. The 3 makes it 3 times taller. The 1/2 makes it come up only half as tall. So multiplying by 3 was a vertical stretch factor of 3. The 1/2 was a vertical shrink. Factor of 1/2. Okay, to sum all of this up, when we have f of x equals the log, we're going to say a log of x minus h plus k. Okay, so we look at all of these things. The a is your stretch and shrink. That's a vertical stretch or shrink, sorry. H inside your parentheses, that's left and right. If it's a minus, then it's going to go right. So right would be a minus. It'll go left if it's a positive, opposite of your intuition. The K outside your parentheses is up and down. Up if it's positive, down if it's negative. Oops, negative. Okay, the other things we looked at are as if you have a negative out front, this will reflect the x-axis. If you have a negative inside, that'll reflect the y-axis. Okay, so those are the things that we've seen. Tomorrow we'll do some more practice with those.